we're going to talk about special right triangles. This is an easy follow-on from the basics of Pythagoras. The Pythagorean theorem is going to be an absolutely key tool from now on. It just shows up so many places over and over again. And it's going to lead to two special triangles that are worth memorizing in terms of that if you know it has certain special angles, then the side relationships are always going to be known. Easy to derive these guys, so we'll just jump into what's called a 45-45-90 triangle. So clearly, if you have a right triangle, that's why Pythagoras is going to apply, and this angle, say at E, is 45 degrees, then you know that the other angle has to be complementary to that, and of course that also means it's also 45 degrees. So in particular, this is not just a right triangle, this is an isosceles right triangle. So that's another name for a 45-45-90. So that means this side GF, we call this side X. We're going to be solving for a relationship between X and the hypotenuse, which we're going to call Y. We're going to solve for a relationship for that in a second. If EF is X and this is an isosceles triangle, then clearly FG is going to be X as well. Let me just go ahead and show that right now. Okay. And then we just set up Pythagoras and see what happens. It says that y squared, that hypotenuse squared, is always the sum of the squares of the lengths of the sides, and that's 2x squared. So that's a true fact. Y squared equals 2x squared, but we usually square root both sides. And so it's going to be the square root of the quantity 2x squared. Let's do that carefully. That's going to be anytime you have the square root of a product, it does turn into the product of the square roots as long as everything's positive. You're not using weird things with i's and stuff like that. And then the square root of x squared, that can be a little subtle, I have to say. If x was a negative number, that would be rather subtle, but since x is a length, the square root of x squared really does get you back to where you started. We'll talk probably in the spring, we'll remind people that that can actually be really subtle if x is negative. It's not an issue here, okay? But I wanted to advertise it. So let's just summarize that in one line. Y equals, and you know, we usually put sort of simpler stuff in front of more complicated stuff. So we're actually going to say x times root 2, just like that. And I'll, whoops, delete that to get rid of it. Okay, so how would we use that, for example? So if, for example, x equals 10 centimeters, hello, then y, you just plug it in. It's just the easiest thing. 10 root 2 centimeters. Usually, we're often going to leave that as an exact rational expression because we're trying to learn the deep math of this. But if you wanted to do, to get the decimal, then that's going to be 14.4, and it's kind of going off the screen. So, okay, about 14.414 centimeters. You can also go backwards, right? Suppose that, let's say y, it's going to be slightly harder. Suppose y is 6, let's say feet, just to be different. Okay, then we've got 6 equals x root 2. Okay, so solving for x is going to be 6 over root 2. And you've learned a little bit about this. This is a good place to practice it again. We typically don't leave things in this form because it can be made a little bit simpler, and that's called rationalizing the denominator. I'm just going to rewrite it again, and I'm going to multiply it by 1 in a special way, which is I'm going to multiply it by root 2 over root 2. What that's going to accomplish is it's going to simplify the denominator, because root 2 times root 2 is going to be 2. That doesn't make the roots go away. It just tends to moves them up into the numerator, but that is a simpler place for things to be because the denominator of a fraction is the more complicated part in a lot of ways. So in fact, here, we can actually kill the denominator completely because 6 happens to be an even number, and that 6 over 2 cancels down to a 3 over 2. It doesn't always happen, but it's nice when it does. So I would say 3 root 2 definitely looks simpler to me than 6 divided by root 2. And so we do want to do that. It's not because there's anything absolutely horrible about 6 over root 2, but we want to practice our simplifications whenever we can. Okay, so next one, we've got a 30 60, let's see if I can do this, 90 triangle. And that is something where we have to do just a tiny bit more work, but it's a really pretty story. Let me bring it up. Okay, so here's a 30, 60, 90 triangle. It's being rather shy. It's at the very far edge of the screen. That's because I'm cheating a little bit, because I'm going to show you the trick to analyze this. If you're given a 30, 60, 90 triangle, stand it up on its short leg so that the 60 degrees is over here, and then flip it across. Copy it by flipping it, reflecting it across the long leg. Well, what kind of triangle have we now created? I think it's not too hard to figure out. That's going to be something with a 60-degree angle, a 60-degree angle, and a 60-degree angle. And so what we've seen is that this is just half, I don't think I'm on math mode, half of an equilateral. This is a really good one because this one, people tend to forget the key ratios of sides here. A little more than with 45, 45, 90. And it's really nice to be able to just rederive this on the fly because it's not incredibly hard. Okay, so let's label the sides here as well. All right, so now I've labeled, I've said AB. We're just going to use X for that, similar to what we did before. We're going to say BC is Y. We're definitely going to need to figure that out. And I've already gone ahead and taken advantage of one crucial thing, which is that AC, that's one side of the big equilateral triangle. Well, that's congruent to the bottom, which is just 2 copies of X because we flipped that over. And so AC is just 2X. I'm not even going to use a different letter for that because we can just say, okay, that's 2X. And now it's pretty simple. We use Pythagoras again, and we say that X squared plus Y squared is equal to the quantity 2X squared. Notice crucial parentheses there. We double X and then we square it. So easy thing to get wrong. And so I'm just going to rewrite that as 4 times X squared, right? That's 2 squared times X squared. Crucial algebra stuff. Okay, and so now let me just subtract X squared from both sides. So Y squared is going to be 3X squared, square root both sides, and we have Y is root 3 times X, and we'll put the X in front. Make it a little bit prettier. So that's so we don't accidentally confuse it with something where the X is inside the root in particular. It's a nice place to put it. There we go. Very similar to the 45, 45, 90 story. And so notice what we've got is that the ratios in the triangle, we're going to really focus on the ratios here. And it's the hypotenuse over the short leg is 2. The long leg over the short leg, that's what we just figured out. That's Y divided by X. That's root 3. And then what else do we want? We want the long leg. There's a bunch of ratios we can do. There's 6, in fact. The long leg over the hypotenuse, let's see, let's calculate that. That's X root 3, whatever X is, over 2X. The X's cancel, and we get that's root 3 over 2. So we're going to come back to this in the very next section. We're going to call this simple cases of doing trigonometry, where we very much focus on the ratios here. So let's give an example, just with explicit numbers. Suppose we know that, let's make it a little bit tricky. We know that the long leg of a 30, 60, 90 triangle has length 30 centimeters. What are the other 2 legs? Okay, so let's see. So that's Y equals 30. We like to solve for X, but we know that Y is also X times root 3. Okay, so we're going to solve that. X is going to be Y divided by root 3, or in other words, 30 divided by root 3. My bad. Once again, we'd like to simplify that. We're going to multiply both top and bottom by another root 3. You can't just multiply just the top or just the bottom. You have to be multiplying by 1, and that's what this does. And then that gives you 30 root 3 over 3. Once again, I set it up to demonstrate that sometimes you get a very, very nice situation where you might get a numerical cancellation. So 10 root 3 centimeters. And sorry, it's going off the page. Let me just make it so it's not going on. Okay, so 10 root 3 centimeters. So that's the short leg. And then the long leg is just 2x. That's going to be 20 root 3 centimeters. We could have gone directly if somebody just asked about the long leg, or sorry, the hypotenuse. If somebody just asked about the hypotenuse, then we could have gotten to here a little bit more directly, but honestly, not a lot more directly. And so people sometimes prefer to go sort of a slightly roundabout way here when it makes more sense to them. We'll definitely do a lot of practice with this, and we'll practice this in more general cases where it's not just these special triangles. But this is enough for now.